remember our BlueTree signature technique before we go into open-ended question. Now, if you have been watching our episode regularly from our BlueTree YouTube, you will have familiarized yourself with what is A.B.C technique. And what is A.B.C technique? A stands for? Yes, that's right, answer with a choice. And B stands for back with evidence. Normally back with evidence, you always refer to the question information. And C stands for confirming concept. So now, not every question requires an A.B.C technique. Some question doesn't require fully all the technique on A.B.C technique. Some question just require on A, answering with a choice, and some question just require a B and a C, a mixture of it. So let's take a look at some of the open-ended questions from this chapter on water cycle. Let's take a look at this open-ended question on water cycles. It says here, on a sunny day, Sally placed two plastic cones, cone J and K, on a wet sand. Cone J and K were similar, but J has a larger opening at the base than K. After several hours, she saw some water collected at the base of each cone as shown below here. Now, explain how water was actually collected. Now, the key concept that we're testing here will, of course, be evaporation and condensation. The next information that we want to look for is always highlight the important hint that can lead us to the concept. So we highlight on a sunny day. Why? Because when there's a heat source, then we know that there is evaporation that occurs. The second hint will be cone J and K. Even though they were similar, there were a larger opening at cone J, but there's a smaller opening at cone K. And lastly, she saw some water collected at the base of each cone. Now over here, I would like to bring you guys to a different question. Now you can recall some of the questions from the topics on water cycle actually asked the student on where water was actually gaining heat and into warm water vapor, and water droplets will be collected in the basin here. Now this diagram look a little bit similar like that, but it's actually not talking about that. But in this diagram, it's actually talking about the ending result should be the water that was actually collected at the base of each cone. So please don't misunderstand this question that water was actually evaporated from the cone at the side of the cone. But in this question, the water that was collected at the side of the cone was actually the end part of the result. So that means to say that if this is a wet sand, depending on the opening, the water from the wet sand will actually gain heat, which you can see this arrow here that I have drawn. So once the water gains heat, it will evaporate to actually form warm water vapor. Now warm water vapor, since there's no opening, warm water vapor cannot escape. So warm water vapor will actually loses heat to this cooler surface area, which is the inner side of cone J and the inner side of cone K. Then water droplets is then formed. Then it then flow downwards here to be collected at the side of cone K and cone J. So as such, our answer to the open-ended question will just require concept. So in this case, we say that step by step in sequence. So the first sequence will actually be water from the wet sand. That is number 1, option 1. Gain heat and evaporate into warm water vapor. The warm water vapor will then rises. Once it comes in contact with the cooler inner surface area of the cone, it will lose heat. That will be step 3 here. Alright, once it loses heat, it will then condense, step 4, to actually form water droplets. And these water droplets then flow down to the side of the cone and is collected. Now, I know that this question doesn't have the A.B.C technique, but only require the concept technique. So this is one example of the question that I mentioned earlier that doesn't require all A.B.C technique. So as such, I want to highlight the important keyword to you here that is used in question like this for water cycles. So take note on the keywords such as gain heat from, evaporated to warm water vapor, cooler inner surface area, and condensed to form water droplets. And let's continue to part B. A similar question, but right now part B is actually asking less water was collected in cone K than in cone J. Explain why. So again, the key concept said it's similar. It's talking about evaporation and condensation. But in this case, they asked how come less water was actually collected in K here as compared to cone J. Now take a look at the water level in the diagram. Truly, they are different level. The water level in cone K was actually much lower as compared to the water level in cone J. Now the reason is because there's a few evidence. One of the evidence is what is circled in blue here, that cone J has a larger opening. So remember the rate of evaporation, the factors affecting the rate of evaporation. You can remember it through WET, wind speed, exposed surface area, and temperature that will affect the amount of evaporation. So in this case, talking about exposed surface area. Now in cone J, since we have a larger exposed surface area, that means the water from the wet sand will gain heat much more. So evaporation is much more faster in cone J. While as compared to cone K, since you have a smaller opening, the water from the wet sand will still gain heat and evaporate, but it is at a slower rate of evaporation. So as such, we can write down our evidence. Evidence is always referring back to the question. In this case, it says that cone K, the opening was smaller as compared to cone J. Because of that, then we can add on to the concept. And because in cone K, the opening was smaller, that means the exposed surface area of the wet sand is in contact with the surrounding and will be much more slower. That means the heat gain and the evaporation was actually reduced. So if the heat gain and evaporation is reduced, that means we'll have less water vapor, less water droplets, because less water vapor will condense onto the cooler surface area to form less water droplets. As such, the rate of evaporation and the rate of condensation also becomes slower. That's the reason why you have lesser water collected here at the site in cone K, because of the exposed surface area in the middle, which has a smaller opening. And of course, definitely, I need to let you recall the keywords again. So in this, you realize in the topic on water cycle, keywords are very important. Now, I suggest to you to take a journal to write down all the keywords that you are familiar with the topic on water cycle. So in this case, you can see I used the keyword on exposed surface area and I used the keyword on rate of evaporation and condensation, which was much slower. Therefore, less water was actually collected in cone K.